Hello, algebra students. So I just want to do a few slides of the make it balance activity, make sure we understand what's going on here. And this is related to the worksheet that we were doing in class on Thursday, where you were estimating centers and using the mean as a balance point. So our basic idea is we're trying to figure out where do I place this to balance out the two bears with each other. If I put it too close on one side, things will tip the wrong direction. If I put it too close on the other side, they'll tip the other way. The way to balance it is to make sure there's an equal distance from both sides. So if I put it on 4, there's an equal distance on both sides. The direction to the right is 3 steps. The direction to the left is 3 steps to the left. I'll put that as a -3 just to tell you the difference between going left and right. And those add up to make 0. And that's the whole idea, that 0 is the balancing point of your number line. And you can use that to complete all of these challenges. So let's look at the next slide where things get a little bit more interesting. Here we go. Two bears. I can put them anywhere as long as the distance from the balancing point adds up to 0. So this is a distance where we have one step to the right, one step to the left. So a +1 and a -1. I could have done it differently. I could have done the cheap way, put them both just right on the balancing point. Now they're both a distance of 0. Or I could have put them farther away. Let's say, I don't know, what is that? 4 steps to the left, so that's like a -4. 4 steps to the right, and that still is a total different distance of 0. Gets a little more interesting. Uh, we talk about the number of solutions here. I can put the bears anywhere along away from this balancing point. I can put them both at 5, or one at 6 and 4, 7 and 3, 8 and 2, 9 and 1, 10 and 0. If I could put them in between, I could put them an infinite number of places. When you have 3 bears here, you have to make sure that the total distance is equal to 0. So if I just try putting it at 5, it's too heavy on the right side. So I know I need to move further to the right. Let's try 6, and that looks balanced. And the reason that 6 is balanced is because we have a distance here to the first bear of 2, and we have a distance to the second bear of 3, and we have a distance to the bear on the left of -5. And so that makes it balance out to equal 0. And so that's the thinking here, is that the balancing point is equidistant from all of your other points. Another approach to this problem would have been to add up the positions of the different bears and find the mean. So another approach, instead of trying to think of where is the distances adding up to 0, another approach would have been saying, I have a bear at 1, I have a bear at 8, and I have a bear at 9. All of those bears add up to 18. There are 3 bears, so I divide by 3, and I get 6. But the point I'm trying to get across is that finding the mean is the same thing as finding the point that has equal distances to the right and equal distances to the left. So that's all I wanted to go over, but please ask more questions if you want follow-up videos on this concept. Thank you.